So another way to think about the learning objective 2 for Unit 3 here in Algebra 2, finding and classifying discontinuities of rational functions, what we're really trying to find is the exclusions. In other words, what values of x would cause the denominator to be 0. Rational functions, again, are functions made up of one polynomial divided by another. Sometimes that means we're going to have a 0 in the denominator and we're not allowed to divide by 0. So really for numbers 2 and 4 here, where we're trying to figure out what the points of discontinuity are, we just really want to figure out what x values would make the denominator 0. And when we have that situation, we have a discontinuity which would either be a removable discontinuity or a non-removable one. We'll talk about that. If we have a removable one, that would be physically a hole in the graph, and a non-removable discontinuity, that would be a vertical asymptote. So just to make sure you understand, for rational functions, there's only two types of discontinuities: a removable discontinuity or a non-removable one, and they're really, really easy to spot when you know what to look for. So the first thing we have to do is we have to factor the denominator. We get x minus 9 times x plus 2, and so we identify the discontinuities are x equals 9 and x equals negative 2, because 9 minus 9 is 0, and negative 2 plus 2 is 0, and 9 and negative 2 make the denominator equal to 0. 9 makes this factor equal to 0, and negative 2 makes the second factor equal to 0. So we've identified the discontinuities. Now we have to classify the discontinuities. Classifying the discontinuities means we have to figure out if they're removable or not, and that requires the use of factoring the numerator. And noticing the numerator is we have a common factor of x, and when we factor out an x, we get x times x plus 2. Now, once we factor both numerator and denominator, we look for the two factors in the denominator. Do we have a common factor also in the numerator? And we can see we have an x plus 2 that is a factor in both the numerator and denominator. So if we reduce the fraction, we can cancel those factors, because x plus 2 divided by x plus 2 is just 1. Simplifying the fraction, we cancel those factors out. As soon as you cancel a factor, the 0, meaning here, if x plus 2 is a factor, its corresponding 0, or the number that makes that factor equal to 0, negative 2, we've just removed the factor, and so the corresponding discontinuity is called removable. If we remove the factor, the corresponding discontinuity is called a removable discontinuity. And physically, again, that would be a hole in the graph, and we'll talk about that later. Now, notice that the factor of x minus 9, which corresponds to the discontinuity of x equals 9, didn't get removed. It didn't get canceled. So we call that a non-removable discontinuity. And that's really it. That's what we're trying to do for numbers 2 and 4. I'll do number 4 in a different video.